Welcome to our presentation. So our paper title is A Model for Identifying Historical Landmarks of Bangladesh from Image Content Using a Depthwise Convolutional Neural Network. So here is the list of authors. We are 4 and on behalf of them, me, Tanjila is presenting here. So, in the introduction part, I would like to talk about the work we have done. So, in this paper, we have proposed a CNN model based on MobileNet and TensorFlow to identify some historical places of Bangladesh by analyzing their image. Our model is built on Depthwise distinguishable filter, and we applied those on the dataset of 5 famous historical places of Bangladesh. Here is some of the related work that have been done so far. So in 2012, Alex and his team proposed a deep convolutional neural network to classify the high resolution images in the ImageNet. Though it was better than other existing models, here the time complexity was relatively worse. However, in 2012, some authors proposed an Inception v3 model with GoogleNet, also for image classification. Here, they used 23 million parameters. So, actually, the size of the model became large, and this resulted in high time complexity to run this model. So, in the background of our work, we have used TensorFlow, transfer learning, convolutional neural network, and depthwise separable convolution of MobileNet. So, this is the MobileNet architecture. I'll describe it. Here, the core layers are based on depthwise separable filters. The MobileNet model is a form of factorized convolutions which manufactures a standard convolution into a depthwise convolution. Here, each input channel prosecutes a single filter. The depthwise separable convolution is actually divided into 2 layers, one for purifying and another for mixing. So, here is the architecture in detail. A standard convolutional layer accepts an input of df into m for a feature map of f, and it generates dg into n for a feature map of g. Here df is the structural width and height of a square input feature map, and m is the number of input channels. There are computational costs of standard convolutions as well, and this is the depthwise separable cost of convolutions. So here comes the methodology part. In this paper, we have done our work step by step. So first of all, in the data collection part, we have collected around 750 images of 5 different classes, in which each class has 150 images. The classes are named as Lalbagh, Ahsan Munzil, Panam City, and so on. Now, in the data pre-processing part, we have increased the dataset artificially, but the dataset looks like refreshed data. First of all, we resized the data, and then we used 5 different augmentation methods to actually increase the dataset. They are sharing, translation, flip, and rotating about 30° positive angle and 30° the negative angle. So, a sample of our dataset is provided here in the figure 3. So, here is the trained model of our paper or of our work. First of all, I'd like to talk about the train model. Here we have used 224 1.0 version of MobileNet. This is the biggest version. Here 1.0 is the width multiplier and 224 is the image resolution. First of all, we have made our dataset and then we created a Docker image to handle the training. Then we used TensorFlow, which was pre-installed and configured. Then we defined the default training parameters as an environmental variable that will ultimately override them at runtime when needed. We actually set our image size here to 228 pixels. So after completing the training, the output would be used to recover the trained model. Now here is the confusion matrix of our model, which we have created manually. So these are the equation for finding multi-class confusion matrix, and these are the precision, recall, accuracy and F1 score of our model. We have calculated this using these equations. So it is not possible to calculate every precision, recall or every value. So for time shortage, we have given here the value for only one class, that is Asan Munjil. So here is the result exploration part. Here is the graph of accuracy and cross entropy. Both are regarding training and validation. These have been created in TensorFlow. In figure 5 shows the training progress as a process of accuracy, and figure 6 shows the training progress as a process of cross entropy. Here the orange line represents the training set and this blue line represents the validation set. So we can see these values are really great, and from these following two figures we can say our model has not exhibited any overfitting. So let's come to this bar chart. Here we have given the bar chart for our 5 classes showing the precision, recall, accuracy and F1 score. So this indicates that our MobileNet model has really worked well in our whole dataset. So this is the tables. We can easily understand the difference between Depthwise Separable and full convolution MobileNet. If we had used full convolution MobileNet, then we had to use high precisions and high parameters, so that would be lengthy. And this is the width multiplier table, and this indicates the width multiplier alpha. Here the value of alpha is between 0 and 1, and this is the resolution table. This shows the input resolution multiplier, and if the resolution is decreased, then the accuracy would also be reduced simultaneously. So so far our model achieved around 99.2% accuracy in classifying the historical images of Bangladesh. So comparing to other state-of-art model related to our work, we can say that our model holds a relatively simpler architecture and also achieved a higher accuracy rate. So further, we can also improve our model by adding some more features to the classes and enhancing the number of classes to facilitate image classification in other related areas. So this is the end of our presentation, and thank you so much for hearing.